Okay, here we are, finishing up ELI the ICEman. So we talked about ELI last. So now we stated that ELI meant that the angle of the current was less than the angle of the voltage by 90 degrees in an inductor. And so let's look at that real quick. Basically what I'm talking about is, let's say we have an inductor. And we have the voltage across the inductor. And this is an RMS value, so I'm going to put RMS here. I probably won't be doing that much longer. We're going to say that this is 5 angle minus 30 degrees across here. All right, and we're going to say that this is a J5 ohm inductor. And as with all passive elements, the current, which is going to be an RMS value once I solve it, because the voltage is an RMS value. Once I solve that RMS value, IRMS value, I is an RMS value. So let's look at this. So IRMS is going to be 5 angle minus 30 degrees divided by J5 ohms, which equals 5 angle minus 30 degrees divided by 5 angle 90 degrees. And what I need is a little more space here. Oh, come on. It's not letting me add space. Why not? Oh, there we go. Okay, and this equals 5 divided by 5 at an angle of minus 30. Bring the angle up from the bottom, so that means you subtract it. That's going to be minus 90 degrees. And so this is going to be 1 angle minus 120 degrees. Okay, so look at the angle of the current and come back up here and look at the angle of the voltage, which is minus 30 degrees. And you see that, sure enough, the angle of the current is minus 120. The angle of the voltage is minus 30. The angle of the current is 90 degrees less than the angle of the voltage. And that's exactly what you want to see in an inductor. Okay, so let's go on over to, and let's do capacitance. Let's do ICE. And again, you want to be sure that you know these definitions, because that's the first thing on test 3 and test 4 that I'm going to ask. What is ELI the ICEman and why do we use it? Why do we use it? It's a quick check on your circuit calculations. If the voltage doesn't lead the current, or if the current doesn't lag the voltage by 90 degrees across that inductor, you've calculated it wrong. So ICE basically means that the angle of the current is greater than the angle of the voltage by 90 degrees in a capacitor. Okay, so what does that mean as far as we're concerned? Well, what that means is if I have a capacitor, and I'm sorry, I'm going to use the same numbers again just because it's easier for me. If you have a capacitor voltage across here, and we're going to say that it's 5 angle 45 degrees, how about that? Volts. And this is an RMS value. And this is a minus J5 ohms. Then the current has to enter the plus sign of the voltage drop. And it will also be an RMS value. So if I want to solve for that, this is going to be I, and it's an RMS value. Probably after this, I'm not going to write RMS anymore. So this is going to be 5 angle 45 degrees volt, and it's an RMS value. And divide by minus J5 ohms, which equals 5 angle 45 degree volts divided by 5 angle minus 90 degree ohms, and this equals 1 angle 45 degrees minus a minus, which is plus 90 degrees. And so what I get here is I get that the IRMS is going to be 1 at an angle of, is that 135 degrees? Amps. And it's an RMS value, but that's okay. So if I look at that, 135 degrees leads 45 degrees by 90 degrees. Right? And that's what Eli the ICEman said. Eli the ICEman said the angle of the current has to be 90 degrees bigger than the angle of the voltage when you're looking at voltage and current across the capacitor. And it's all because of the value of the capacitor. Okay. So that looks good. So let's do some circuit stuff, shall we? I don't have a